Today in calculus, we're going to learn about indefinite integrals, which is essentially reversing differentiation. We're going to learn the basics and practice applications with differential equations.
I'm agreeing with what you say.
The indefinite integral of a function, f of x, is the antiderivative of f. The indefinite integral of f is a class of functions all equivalent up to the constant, and we'll talk more about why that is later. The general formula, or the power rule, goes as follows. If dy over dx is equal to a times x to the power of n, then y is equal to ax to the power of n plus 1 over n plus 1 plus c. However, this rule only works when n is not equal to negative 1.
So first we're going to try with x to the 6th power, and to find the antiderivative, we increase the power by 1 and divide by the new power, which would be x to the 7th power over 7 plus c.
C represents any constant that may be added to the equation. A function has multiple antiderivatives.
So we're going to do the same thing again. Finding the antiderivative of x squared, we increase the power by 1 to get x cubed, and then divide by the new power, so divide by 3, plus c. Another antiderivative of x squared also includes x cubed over 3 plus 5. So let's check that by taking the derivative. So we bring the 3 in front to get 3/3 x, and decrease the power by 1 to get 3/3 x squared, which simplifies down to x squared. Another antiderivative of x squared includes x cubed over 3 minus 7, or x cubed over 3 plus 48, and so on. This works because the derivative of a constant will always equal 0, so that doesn't affect the rest of the equation.
Now we're going to take the antiderivative of 8x.
And because this one's a little different, we're going to break it down a little more. So focusing on the x, we increase the power by 1. So since technically it's x to the first power, we do x to the first power plus 1 over 1 plus 1 plus c. So because the 8 is just a scalar, we don't need to do anything to that. So to simplify that, we get 8x squared over 2 plus c, which simplifies down to 4x squared plus c.
It is important to recognize when you are being asked to take the antiderivative. This is the symbol for antidifferentiation. If you see the symbol next to an equation and then dx, you are being asked to find the indefinite integral.
Now we're going to find the antiderivative of 6x minus 4, and we're going to closely follow the power rule formula again. So we increase x to the first power by 1 to get 6x squared over 2. And we can get the antiderivative of 4 by using the power formula too. The 4 in the original function can also be looked at like 4 times x to the 0 power. So if we apply the power rule, we get 4x to the first power over 1, or just 4x. So then we get 3x squared minus 4x plus c. Now we can check by taking the derivative. So we bring the 2 in front and multiply it by the 3, decrease the power by 1, and subtract the derivative of 4x, which is 4. So the answer is 6x minus 4, so we know we've done it correctly. Now we're going to take the antiderivative of 1 over x to the 4th power, and in some cases it's necessary to rewrite an equation before integrating. So we're going to rewrite it as x to the negative fourth power, just so it's easier to integrate. And then we increase the power by 1 to get x to the negative third power, and then divide by that same number plus c. Now we can simplify that down to negative 1/3 x cubed plus c. Now we're going to take the antiderivative of 5 over root x, and this is another one that we're going to rewrite. So we rewrite it with 5 outside of the integral sign, x to the negative 1/2 power. And now we can integrate using the power rule. So increase the power of x by 1, so we get 5x to the 1/2 power over that power plus c, which can be simplified down to 2 times 5 because we take the reciprocal of the denominator and multiply it by the numerator, x to the 1/2 plus c, which equals 10x to the 1/2 plus c. Now we're going to take the antiderivative of the cubed root of x times x plus 7. And this is another one that we're going to rewrite as well, just to make it a little bit easier. And because we have a radical, so we'll rewrite it as x to the 1/3 power times x to the 3/3 power, which is the same as x to the first power, but it just makes it a little bit easier to add, plus 7. And then we can simplify this down to x to the 4/3 power plus 7x to the 1/3 power. And now we are ready to integrate. So we increase the power by 1 to get x to the 7/3 power over 7/3 plus 7x to the 4/3 power divided by 4/3 plus c. And then we can simplify that down to 3x to the 7/3 power over 7 plus 3 times 7x to the 4/3 power over 4 plus c. And then we can simplify that down to 3x to the 7/3 power over 7 plus 21x to the 4/3 power over 4 plus c. The last type of problem we're going to do together is finding the specific antiderivative given an initial condition. So we're given the equation 8x cubed plus 9x squared plus 2 when f of negative 2 equals 7. So first, we're going to find the antiderivative using the power rule as normal. So for 8x cubed, we increase the power by 1, divide by the new power. So 8x to the 4th power over 4. And then 9 plus x cubed over 3 plus 2x plus c. And then that simplifies to 2x to the 4th power plus 3x cubed plus 2x plus c. And then we plug in -2 for x. So 2 times -2 to the 4th power plus 3 times -2 cubed plus 2 times -2 plus c. And then we set that equal to 7 and solve for c. So then we get -4 to the 4th power minus 6 cubed minus 4 plus c equals 7, which is -476 plus c equals 7. Then we get that c equals 483, and we plug that in for c into the antiderivative to give us 2x to the 4th power plus 3x cubed plus 2x plus 483.